The presence of pharmaceuticals, such as acetaminophen and ciprofloxacin, in water is a growing environmental issue of concern worldwide. These emerging contaminants pose significant challenges to water quality and human health due to their presence in water sources and their impact on aquatic ecosystems. Acetaminophen, a commonly used pain reliever, can disrupt the natural balance in ecosystems, while ciprofloxacin, an antibiotic, may promote antibiotic resistance. The main sources of pharmaceuticals in wastewater are: firstly, excretion by humans and animals contributes to the presence of drugs in wastewater. Secondly, improper disposal of medications leads to pharmaceuticals entering wastewater. Flushing unused medications down the toilet or sink is a common practice that should be avoided. Another source is pharmaceutical manufacturing, as small amounts of drugs can be released during production processes. Additionally, hospitals and healthcare facilities contribute to pharmaceutical contamination through the disposal of expired or unused drugs into the sewage system. Lastly, runoff from agricultural lands that use pharmaceuticals in animal farming can further contribute to the presence of drugs in wastewater. It is crucial to manage and monitor these sources to minimize the environmental impact of pharmaceuticals in the water cycle. This study aims to take advantage of the large amount of coffee husks generated and use them as adsorbents for the removal of pharmaceuticals from wastewater. Additionally, it evaluates the effect of pyrolysis temperature on the adsorption of pharmaceuticals. Coffee husks have proven to be an effective and sustainable adsorbent. To investigate this potential, the methodology described below was followed. The coffee husks were transformed in a pyrolysis process in a tube furnace at 300, 500 and 700 degrees Celsius to produce adsorbent materials at these conditions. Subsequently, these materials were evaluated for their ability to remove ciprofloxacin and acetaminophen in batch experiments to find the adsorbent with the highest removal efficiency, as well as the kinetic and isothermal parameters. Results and discussion. Untreated CH showed high ciprofloxacin removal efficiency, 64%, but upon heat treatment, the efficiency decreased due to the loss of functional groups. On the other hand, acetaminophen removal was null due to its neutral form at pH 5.17 and lack of electrostatic attraction with CH. These results highlight the importance of functional groups and pH in the adsorption of contaminants on coffee husk. Finding that the best adsorbent is the untreated husk, the following experiments were performed with CH and ciprofloxacin. The pH is crucial in adsorption studies. It was observed that the removal of ciprofloxacin is maximized at pH 6 and 8, with removals of 62.36% and 61%, respectively, due to electrostatic interactions. At pH 2, the removal is low, 1.91%, because the material is positively charged, and the ciprofloxacin is mostly in cationic form. The results are explained by the speciation curve of ciprofloxacin, where electrostatic interactions favor adsorption at pH 6 and 8. In the kinetic studies, it was found that when fitting the data to kinetic models, the pseudo-second-order model showed the best fit, suggesting that the adsorption process involves electron exchange through hydrogen bonds between amino groups of ciprofloxacin and OH of the adsorbent. The isotherm model that best fit the experimental data was loose, indicating physical and chemical adsorption. The Langmuir model also had a good fit, suggesting favorable monolayer adsorption with KL equals 0.0235, indicating favorable adsorption. The adsorption capacity of the adsorbent can be influenced by the presence of other components in the solution. Despite this, it is important to note that CH demonstrated satisfactory performance in wastewater matrices, achieving a removal rate of 44.5%. This highlights its effectiveness as a viable adsorbent for full-scale applications. The recovery processes of the adsorbent do not affect its adsorption capacity, with adsorption percentages always higher than 60%. This indicates the stability of the material and its great potential for drug elimination. The CH adsorption capacity is comparable and even higher than those reported in the literature for other types of biomass as adsorbents. This indicates a high performance due to the fact that it is an untreated biomass, being an efficient adsorbent in the removal of ciprofloxacin from wastewater.